Now we are going to learn a new topic, some applications of trigonometry. In practical purpose, we can apply the trigonometric ratios. Let us see how such ratios can be applied in practical purpose or in practical situations. See this. Suppose a man looks at the top of a building or a tree. This is the top of the building or tree. Then we can see when he looks straight, it is marked as horizontal line. And to have a look at the top of the tree or an object above his head, he has to tilt his head upwards. So when the man looks upwards from this point, when he looks straight, we get a horizontal line. When he looks up to the object, to the top of the tree or building, we mark this as line of sight. Then between horizontal line and line of sight, we can find an angle, or the horizontal line and line of sight make an angle this way, from horizontal line to line of sight. This angle is called angle of elevation. Angle of elevation. So, angle of elevation is the angle made by horizontal line and line of sight when a man looks at an object above his head. Looks at an object above his head. Now, another situation is this. Suppose this is a building, and at the top of the building a man looks to an object on the ground. This is level ground. This is also level ground. An object on the ground. So what happens? When he looks straight, we mark it as horizontal line. When he looks downwards to the object, there also an angle is made by these two lines, line of sight and horizontal line. That is from horizontal line to line of sight. Such an angle is called angle of depression. Angle of depression. And remember, angle of elevation and angle of depression, both angle of elevation and angle of depression are measured from line of horizontal line or line of sight. Horizontal line. Elevation, angle of elevation is measured from horizontal line. And also angle of depression is also measured from horizontal line. Now, what is the application of how can we apply the trigonometric ratio here? Suppose this is the distance between the man and the tree or building. We can mark it as B. And this is the height of the building or tree. If one of them is given and the angle of elevation is known, we can find if D is given, H we can calculate. Or if H is given, we can find the distance between the man and the building, or the man and the tree, or height of the tree can also be calculated. If we are given the distance and if the angle of elevation is known. Similarly, if the line of this is the height of the building and then height of the man, then this is the distance between the object and the level ground at the foot of the building, from the foot of the building. So to calculate this, these two, horizontal line and level ground, is taken as parallel lines. These two are parallel lines. Then these two angles, this is the angle of depression. What is the relation between these two angles, this and this angle? They are equal. Alternate interior angles, alternate angles. So to find, we can, instead of this, we can mark the angle here also. Then we can connect height and distance, H and D, height and distance. For example, suppose the angle of elevation is theta Then h is known. Then how will you find d? We can write h by d equal to tan theta. Opposite side by adjacent side. So if h is known, what is d? H by tan theta equal to d. That is distance between the object, distance of the building or tree from man. And if d is known, what is h? H equal to d tan theta. Tan theta. When do we get h and d are equal? If theta equal to 45 degrees. 45, tan 45, 1. So, h by d equal to 1 means h equal to d. Now, suppose we are given this condition. It's the angle of depression theta. We want to find either h or d when one of them is given. Then this angle theta means this angle is also theta. Then tan theta equal to h by d. If h is known, h by d equal to tan theta. So h equal to d tan theta or d equal to h by tan theta. In this way we can find the either height or distance if one of them is given, and also angle of elevation or angle of depression. One of them is given. Now, for example, suppose the distance between the man and the building is 30 meters, and at the top of the building the man sees here the height of the man is negligible when compared to the height of the building, so we neglect that height. Then if the angle of elevation is 30 degrees, what is the height of the building? We can theta equal to 30 degrees, distance d equal to 30 meters. Now tan theta equal to h by d. Tan 30 equal to h, height is not known, 30 meters. So what is height? What is tan 30? Tan 30 equal to 1 by root 3. 1 by root 3. H equal to 30 tan 30 equal to 30 into 1 by root 3 is equal to 30, 3 into 10 by root 3. 3 can be written as root 3 into root 3. Root 3. 1 root 3 cancelled. Root 3 into 10. That is, answer is 10 root 3 meters. This is the way how we calculate the height. Or if we want the distance, the height is to be known, and the angle of elevation or angle of depression is also known. To learn more about this, read the textbook pages 195 to 203 and do the examples 1 to 6. Thank you.